by finishing section 1.3, part 2, okay, which is on functions. We'll do a little bit on the graphing calculator. Not a ton, but we will use it a little bit. So first thing, just want to kind of review how we graph something on the calculator and how you find a good window where you can see everything. All right. So let's start just by typing that in on the calculator. So if you don't remember how to type it in, if you're on another screen like I am right now, first thing I want to do is go back to the screen where I can graph things. So I can get rid of that by pressing Y equals. If there's anything else that's already typed in there, you can go ahead and just clear it by pressing the clear button, which is on the right-hand side. All right, so remember when you type it in, the variable button is the second one to the right and the second one down. It's right on my calculator, it says x, comma t, comma theta. So I'm going to type in 16x minus x cubed. Any questions on just typing that in? Yes?
So I did this over some pieces of work, but I found a new calculator and I haven't been able to get to work. Every single time I go to type something, it just says error and then mention mismatch.
Gives you an error? Okay, so what you want to do there is go to y equals, and see how plot 1 is highlighted in black? Hit up, and then hit, so it's blinking, now hit enter. And now we turned it off.
Right.
So now hit graph and you should be all set.
Oh, fun. Thank you.
Yep, you're welcome. Other thing to remember, big difference between the negative symbol and the subtraction sign. We are using a subtraction sign here, not the negative symbol. All right. And then what's the window that we normally start out with? We press zoom, and does anyone remember? Yep.
You press zoom, that's
6. That gives me a window from negative 10 to 10 and negative 10 to 10. Okay, so that's not a good window. It almost looks like it might be turning or it might be connected, but there's a value I need to adjust here. Actually, 2 values. Which 2 values do I need to adjust so I can see this graph a little bit better? Yep, go ahead, Jess.
X max and Y max.
Okay, so X max is going to let me see further to the right. Maybe we need to see further to the right, but I definitely agree with the Y max. We do need to see a little bit more up. And where else do we want to see? Yep.
Y min.
The Y min. So maybe we want to adjust the X max later. I don't know. But let's start with the high and the low. So instead of negative 10 to 10, let's just a guess. Let's try negative 30 to 30. And let's hit graph again. That's good. That's what a graph should look like that has an exponent of 3 in it. It has a graph that kind of curves. Now you can keep zooming out if you want. You can set the Y min like negative 50 to 50 and see even more. But all you're going to see if you keep zooming out is this. It's just going to keep going down, and that just keeps going up. It's not going to turn or do anything else. So that's a good window. All right. So what you would want to write down for the window part is that negative 10 to 10 was fine. And there's more than one answer. You could do negative 40 to 40 for the Y's. You could do negative 50 to 50. There's lots of different answers. What you wouldn't want to do is like negative 50,000 to 50,000. If you zoom out that much, it's going to be too far. You're not going to be able to see it as well. All right, and find the domain and the range. Okay. Let's look at our formula. So here's the formula we typed in. I've mentioned there's 2 things you're not allowed to do in a function. And if you do these two things, it causes a problem. Does anybody remember one of the two things that you can't do when you have a graph? Yep.
Can't do square root of negative.
You can't take the square root of a negative. Okay. Is there a square root in the part that I circled? What do you think? Anyone have a guess? Yep. No, there's no square root in this problem. So you never have to worry about taking the square root of a negative because the square root doesn't exist. Does anybody remember the other thing you can't do? Besides square roots of negatives. Yeah?
Divide by 0.
You can't divide by 0. The only way you would divide by 0 is if you had a fraction and there was a variable in the bottom. Do we have a fraction with a variable in the bottom in the part that I circled, Alexis? No. So the two things that could cause a problem aren't in this question. So what does that mean your domain will be? What is it? So that would be the highest we could go. And what's the lowest? That, yep. Negative infinity. So the domain is all real numbers. You can take any number you want, plug it in for x, multiply it by 16. There's no problem with multiplying a number by 16. And then you can take any number you want and raise it to the third power. There's no number that you can't do that to. So the domain is all real numbers. Now the range. Range is how high and low the graph goes. How high and low does it look like this graph is going to go? Yeah, it just goes up and it goes down forever. So because it goes up forever and it goes down forever, and you never have to lift your pen while you're drawing it, that means you're going to go through every single value up and down. You're not going to miss any of them. So the range is also all real numbers. Negative infinity to infinity. Now that's not a coordinate. Remember, that's an integral. This is the low value, and this is, or I'll say it like this. I'll do it like a calculator does. This is the min. This is the max. And parenthesis means don't include it. We always put a parenthesis on infinity because you can't reach it. Okay. Any questions on finding a complete graph or the domain and range? All right. Let's see. I think. All right. Let's try this question. So we're going to use the graphing calculator to help us figure this out. So it says we have a pool that's 30 feet by 50 feet. Okay, let me draw that first. So I have a rectangular pool, like that. And this is 30, and that's 50. That's the pool. It says there's a sidewalk around the pool, and it's the same width all the way around. So let's put a sidewalk all the way around the pool. So that area, that's the sidewalk. We don't know how wide it is, but they tell us to call that width x. Okay, so it's x. That's the width of the sidewalk. They tell us the area of the sidewalk is 600 square feet. Find the width. Okay. So the width of the shape of the sidewalk, it's not really a rectangle. It's somehow that we have to figure out how do we find the area of that shape of the sidewalk. It's kind of like the border of a rectangle, and it has a thickness of x. So let's call the outer rectangle the big rectangle, and the inner rectangle, well, that's the pool. Does anybody see what I could do if I knew the area of the big rectangle and the area of the pool? Do something with the two of them to find just the area of the sidewalk that's around the pool. Yep.
You just subtract the area.
Yeah. If you take the area of the big rectangle, that's this whole thing like this. And if you subtract the area of just the pool, then you'd be left with the border, which is the sidewalk. So this is the idea of what we're going to try to do. Find the area of the big sidewalk and subtract the area of the pool. Now the area of the pool we know, that's a number. Okay? The area of the sidewalk, we know that number too, 600. What we don't know is x. All right, so let's see if we can figure out a formula for the area of the big rectangle. I'm going to move these lines off so it doesn't look as confusing. You can see it a little better. What's the formula for the area of a rectangle? Yeah. Length times width. So let's just put that off to the side. So area is length times width. And let's start with the big rectangle. So the big rectangle is that long for the length. Now, if I put these dotted lines like this, how much is the section that's right there? That's 50 feet. How much is this section that's on the end, and then this section that's on the end? Yep.
X.
They're x and x. So if you add that all together, that's the length of the big rectangle. It's x plus 50 plus another x. So that's 2x plus 50. Okay, so let's write that down. So area of the big rectangle is 2x plus 50. That's the length. Now I need the width. Same idea. That's the width. We draw those lines over. This part is 30 from there to there. So does anyone think they could tell me what the whole width would be? Yep. 2x plus 30. 2x plus 30. So there's the area of the big rectangle minus the area of the pool. So we're going to subtract the area of the pool, and that we can figure out. That's 30 times 50. So multiply that out. Yep, we get 15. Yeah, you get 1,500. So remember, this is the formula that's going to give you the area of the sidewalk if you subtract the big minus the pool. Now, they already told us the area of the sidewalk. How much is the area of the sidewalk in this problem? 600 feet. And there's our equation that we need to solve. Okay, so this first part is something we did back in Algebra 1. You have to FOIL this out, just like that. So Caleb, if I start to distribute this out, what's 2x times 2x?
4x.
2x times 2 would be 4x.
Oh, that'd be 4x. It would be 2x to the second.
So what's 2 times 2?
4.
So that's your 4, and then x times x.
Yes, 4x.
X to the second. Yeah. So 4x squared. Sam, what's 2x times 30?
60x.
All right, let's put that right there for a second. 60x. And what's 2x times 50?
100x.
100x. And if you combine those together, how many x's?
160x.
160x. And then 50 times 30 is 1,500. So plus 1,500. But then also we have that minus 1,500. What's going to happen on the left now? They're going to cancel out. And now we have what's called a quadratic equation. It's an equation where the highest exponent is a 2. Generally, when you want to solve a quadratic equation, Does anybody remember what number you want it to equal? You don't want it to equal 600. Yep. 0. Okay, you want to get your equation equal to 0. So, Chris, how would I move the 600 to the other side so I'd be left with nothing over here?
You would subtract 600 from both sides.
Yep, subtract 600 from both sides. And that's how we set it up to solve a quadratic equation. Now, if you can, and every number is divisible by something, it does make it easier if you divide everything by that number. You don't have to, but it makes the numbers smaller. Does anybody see something that I could divide all 4, including the 0? Yep.
You can divide by 4.
Yeah, you can divide everything by 4. Again, that's not necessary, but it will make it a little bit easier. So x squared plus 40x minus 150 equals 0. Okay. Several ways we can solve that kind of problem. One of the main ways is factoring. But factoring only works if the numbers are nice. And I'll give you again, that's not going to factor. The other way we can solve a problem like this is the quadratic formula. So the quadratic formula, probably the best way to solve this one. You could also graph it on the calculator and do it that way. But let's do the quadratic formula just to remember what that is. So if you don't remember from Algebra 1, there's your quadratic formula. So it has 3 letters in it. A, B, and C. Looking at my equation up above, does anyone think they can tell me what each of those letters are? Yep.
A is the x2, B is the 40, or it's not the exponent. A would be, sorry, A is 1,
Yep.
B is 40, and C is negative 150.
Yep, so these are all numbers. And the A is the coefficient of the x squared, B is the coefficient of the linear term, and C is the constant. Once you have those 3 numbers, by writing it just like this, equal to 0, you fill them into that formula and see what you get. Now, plus or minus is part of this formula, which means that's 2 answers. Well, we're dealing with a width of a sidewalk. So before we even start, what kind of number should we be looking for if it's a measurement of a width? Yeah?
Positive.
Positive. So one of these answers is probably going to come out positive. The other one is going to come out negative. The negative one works algebraically, but it does not make sense in our word problem. So the negative answer we're just going to cross out. Okay, so let's see what happens. So we've got negative 40 plus or minus square root of b squared is 1600, and then 4 times 1 times negative 150 all over 2. Now, if you look under the square root, you're going to be subtracting a negative number. So what happens when you subtract a negative? It becomes a positive. So I can make those positives right now. All right, let's see what we get. So we have negative 40 plus or minus. What's 150 times 4? Yep, 600. And what's 600 plus 1600?
2,200.
2,200. And there we go. There's our answers. Let's just use the calculator and see what that comes out to. So I'm going to do the plus first. Negative 40 plus the square root of 2,200. So that's the numerator. And the denominator is divide by 2. 3.45. Since that one came out positive, that has to be the right answer. if you do negative 40 minus the square root of 2200, you're going to get a negative number. And when you divide it by 2, it's still going to be negative, and that won't make sense in this problem. So the answer is 3.45 feet. Okay, so just a little bit of a review on how you solve a quadratic equation. Any questions, or anybody still need to copy that formula down? Questions? So this problem, when we went to solve it, we created a quadratic equation. Highest exponent was a 2. There's one more type of application in this section that has equations with exponents of 2. And that has to deal with projectile motion. So projectile motion is basically if you were to throw an object like that. Projectile. Anything you throw becomes a projectile. Right? And that's the path that it would generally follow. It might go higher or it might go longer, but that's the path of a projectile motion. It's kind of like a parabola. Most. So that's why we use this formula that has the highest exponent of a 2. Because we know formulas that have an exponent of 2 look like a parabola. And this negative 16, that comes from physics, so we're not going to worry too much about that. But the formula is negative 16t squared. And then there's a couple variables. Plus v sub 0 t. Well, there's really a couple things that are going to control how this object travels. One is how hard did you throw it? What was the initial speed that you threw it at? And the other thing that can control how high it's going to go is what was the initial height when you threw it? Were you on a building and you threw the object off the building? Well, if you threw it off the building, then it already has an initial height to start with. If you're throwing it from the ground, then it doesn't. So S sub 0 is the initial height. If you are in physics, you might see a slightly different formula because physics, a lot of times you use meters. You don't use feet as the length. Well, we're going to use feet. So any problem I give you will give you feet, and it will give you seconds for the time. So let's look at our problem, and we want to try to make sure we can find those two things in the word problem they give us. All right, so it says we're shooting a rocket from ground level with an initial velocity of 64 feet per second. So, the initial velocity, that one's pretty straightforward to find. What's the initial speed of the rocket? 64. Yeah. What's the initial height? 0. You're shooting the rocket from ground level. So that means when we do this one, you don't even need this part. We're not going to use it in this problem. It's a plus 0 for the initial height. All right, so let's see what they want us to know. They want to know when the rocket will be 50 feet above the ground. Now, we could do this problem just like we did the last one. We're going to end up with a quadratic, and we could use quadratic formula. But we did that. Let's do something a little different. Okay, this time we'll use the calculator. And we could have used the calculator on the last problem too. I'm trying to show you both ways. Okay, so to figure that out, the first thing we need to do is write our formula and fill in all the numbers they give us. So the height as a function of time. Because if you ask me how high this object is, I would say, well, when? You want to know 1 second after you threw it? 2 seconds? 3 seconds? So the height depends on the time. We start out with negative 16t squared plus, what number is going to come right after the plus sign? Yep.
64.
64. And then we put a t. You don't have any initial height, so you don't even have to put plus 0. Okay, so here's our formula. And remember, this is the height. They give us a height of 50 feet. So would I plug the 50 feet in on the left, or would I plug 50 in for t on the right?
Wouldn't it be for S?
Yeah, this is the height. 50 is not a time. This isn't 50 seconds. This is 50 feet above the ground. So that's going to take the place of that box. 50 equals negative 16t squared plus 64t. It's exactly the same type of equation we have in the swimming pool problem. We have a number on one side and something on the other side with an exponent of 2. Let's go back and look at it for 1 second. We had a number on one side, 600, and then something with an exponent of 2. So we could use quadratic formula. But this time, let's graph that. Okay, so to graph it, you've got two things. You're going to plug that in for y1, and you're going to plug this in for y2. Okay, so if you got anything in there, you can just clear it. You do have to use x for the variable. You can't use t, so just remember that. And before you hit graph, what should you always adjust first? Always adjust the window. Now, I can already tell by y1, y equals 50. That's a horizontal line at 50. So my y max has to go to at least 50. I would go beyond it. I'd probably go even like 80. Just give yourself plenty of extra. Y min, well, that's the lowest height that this object could have. What's the lowest height that would make sense in this problem?
0.
0. We can't go below that. T is time. What's the smallest amount of time you could have in this problem? 0. The biggest amount of time, we don't know. It depends how long it's in the air for. We'll leave it at 10, and if it goes off the screen, we'll make it higher, further to the right. Okay, but let's try that as our window. So there's our height of 50. Okay, we didn't need 10. This object looks like it's only in the air for 4 seconds, roughly. But 10 is fine. So, at what time will the rocket be 50 feet? And that's it. I think they mean exactly. Like, when is it exactly 50 feet above the ground? How many times is the rocket at exactly 50 feet? Twice, on the way up and on the way down. So I need to calculate these two spots. Does anyone remember what those are called? What the thing on the calculator is called to do that? Yeah.
The intersect thing.
Yeah, the intersect. And do you remember how to get to it?
Trace.
Just press trace.
Yeah, I think 4 second trace.
second trace.
And then 5.
And then option 5. Yep. Now, because there's 2 of them, it's only going to give you one at a time. So it does make a difference where you put your cursor. Okay, I'm going to do the one closer to the right. If somebody else could do the one more to the left, that would be helpful. Yes.
I think I messed up my window. Can you go over what your window is again?
The window is 0 to 10 and 0 to 80. And the graph was, well, right here, 50 on y1 and negative 16t squared plus 64t. Yep. All right, so second calc, intersect, 1, 2, 3. So on the way back down, this object hits 50 feet at 2.94 seconds. We'll call that T2. And how about on the way up? Does anybody have the time that it hits 50 feet on the way up? Yep.
1.06.
1.06. All right, thank you. And those 2 answers could have been figured out with the quadratic formula when you did plus or minus. That's how you would have gotten both of these answers. Okay. Any question on how we did those intersects? Yeah.
Wait, so how do you get into 0.94 minus the 1.6?
You have to do second calc intersect again, but you have to move your cursor closer to the other one.
Okay.
Because the calculator can only give you one at a time.
Okay.
Yep. You're welcome. And the last question they ask is, what is the highest that it goes? What is the maximum height? And at what time do we reach that height? So that's something we want to calculate. So it's under the same menu as intersect. I don't know if we've done a maximum before, so I'll show you how to do it. But it's second calc, option 4. Now, am I interested in the maximum of like how high the blue line goes or the red one? Which one am I interested in? Yeah, the red one. Well, right now my cursor is on the blue one. So if I just press left and right, it's just moving on the blue. If I hit up, or if you hit down, it'll move you to the other one. Okay, so you want to make sure, first of all, that you are on the red parabola. The first thing that it asks me for is left bound. That means go to the left of where you think the maximum is, and then hit enter. That's pretty good. Once you do that, it'll ask you another question. Right bound. Go to where you think the right of the maximum is, and hit enter. Now, the last thing is the guess. The guess doesn't really matter. It'll automatically find the maximum for you because you put those left and right bound in. So you can just hit enter a third time. And here's the answer to our problem. We just have to make sure we know what that means. So what is the highest that the rocket goes in this problem? Yes.
64 feet.
64 feet. And when does it hit 64 feet?
Pretty much right on 2 seconds.
Yeah, it's 2 seconds. We just round that off. So the max height is 64 feet. And this happens at 2 seconds. So you can write your answer that way, that's fine. Any question on that? So that was the first part, 1.3 part 2. And we'll finish up with 1.4. I think most of 1.4 is going to be a review, so I'll probably go a little quicker through it. It's like y equals mx plus b, slope, rise over run. So this stuff should be pretty familiar. And I just said this. Does anybody remember what's the slope-intercept form of a line? Starts out y equals? Yep. Y equals mx plus b. And there's an m and a b. Those stand for something. Does anybody know what the m stands for? Yep.
The M is like the slope.
Slope. And what about the b? Yep.
The line.
That's your y-intercept. Y-intercept is just a fancy way of saying where it crosses the y-axis. And when you graph something that's in y equals mx plus b form, it looks like a straight line. It doesn't curve, it doesn't turn. It's perfectly straight. So we call this type of thing a linear function. In the last section, we were dealing with something a little more complicated. Those were quadratic functions. They had a U shape. This is a little simpler, linear function. The m and the b can be any number that you want. They can be positive numbers, they can be negatives, fractions, or decimals. The only thing is m cannot equal 0. Because if you plug in 0 for m, well, 0 times anything is 0. What you've essentially done now is you've wiped that out. Now you have y equals, and you'd have a number. That's called a constant function. In order for it to be a linear function, the slope has to be a number that's not 0. Any questions on that? Now, there's other ways you can write lines besides y equals mx plus b. We'll talk about them real quick, but that's the most common one that we will use. I don't think I'm going to do that one. Slope. Let's talk about slope. I think I said this earlier, but there's 2 words that we use to describe slope that begin with an R. And we usually write them as a fraction. Does anybody know the 2 words I'm thinking of to describe slope, Max?
Rise and run.
Yep, rise over run. And the way you calculate rise over run is with this formula. You have to have 2 coordinates. Each coordinate has an x value and a y value. And the way I remember whether the y's or the x's go in the top is y's rhymes with rise. Y's, rise. They're both in the top. So if you remember rise is in the top, think of which letter rhymes with rise. Y's. y2 minus y1. And then x2 minus x1. And that's the formula to find slope. Now there are 2 lines. They're kind of like special cases. Does anybody know what I'm thinking of in terms of like what kind of line you can have that's a special case for finding the slope? Yeah?
Horizontal and vertical.
Yep, horizontal and vertical. That's horizontal. That's vertical. For a horizontal line, the slope is 0. It's perfectly flat. Okay? Left to right. For a vertical line, it's a little different. A vertical line has two coordinates with the same x value. So when you're trying to find the slope of a vertical line, you could end up with something like 5 minus 5 in the bottom. But that's no good. Does anybody remember what happens when you try to find the slope of a vertical line? Yeah?
0.
It's not the same as horizontal. So it is different than horizontal. Yeah? It's undefined. So a horizontal line has a slope of 0. A vertical line is undefined. And those are the two special cases. All right. So let's see if we can take the coordinate 2, 3, and I want to find the equation of two special lines. I want to find the equation of the horizontal line that's going to go through the point 2, 3, and then I want to find the equation of the vertical line. Since horizontal and vertical lines are a special case of slope, they are also a special case of equation. They don't use y equals mx plus b. They're a little simpler. Horizontal is just y equals, and then it's a number. Just like we did in the rocket problem. We did y equals 50. That was a horizontal line at 50. X equals a number is a vertical line. Okay, so these are special cases. So here's the point. 2, 3. What would be the equation of the line that goes horizontally through the point 2, 3? How would it start out?
Y equals.
Yep. And y equals what number? 3. That's the equation of the horizontal line through the point 2, 3. How about the vertical line? How does anything vertical starts out how? Yep, Matt.
You just start out with x
X for vertical, yeah.
equals 2.
And this one is x equals 2. X equals 2 would look just like this. Vertical line, we can't draw those on the calculator. Horizontal, yes. Vertical, no. Any questions on that? Okay. All right, so slope-intercept form, as I had said before, that's probably the best way, or that's the most familiar way that we write lines. But sometimes you might get something like this. And on the test, I may ask you, what is the slope of this line? Or what is the y-intercept? Well, we can't tell easily because the y isn't by itself. So, could someone tell me what would be my first step if I wanted to take 2x plus 3y equals 6 and start to get y by itself? What's the first thing I would do? Jess?
I think you should move the 6 over to the other side of the equal sign.
So you want to put the 6 over with the
Yeah.
with the 2x
Like
and the
move
3y?
everything onto one side and then you'll move the 3y over and then
Okay.
because
Yeah.
when you move the 3y over it's gonna be a negative and then you have to it can be a negative so then you have to change the sign and everything after.
So is there a way we could do it with avoiding that negative?
Probably.
So if we bring the y to the right, then we're gonna have to deal with a negative after. So if we just leave the y where it is and do something else, we won't have to deal with that negative. But if you don't mind dealing with the negative, you could.
Subtract 2x from the side.
Yeah, if you subtract 2x from both sides, this is gone. And now we have 3y equals, and if we're going to put it in y equals mx plus b form, that's how you do it. Now, we have to do something to get rid of that 3, but it's not a negative, so we don't have to worry about that. So how would we get rid of this 3? Yep.
Would you just divide 3 on this side?
Yep, and when you divide by 3, you want to do it everywhere just like that. So I'm just going to come over here. So now these cancel. And we get y equals negative 2/3 x plus 2. So what's the advantage of writing it that way? Why would you want to do that versus what we had up there? Yeah.
You can like see the slope.
Yep. You can see the slope. So like if I had to graph this, I know now I go up 2 on the y-axis, put a dot, and then I go from the y-intercept down 2 and right 3. So it makes it very easy to graph it. That's the advantage. So you may have to take an equation sometimes and rewrite it like that. Any questions on that? So the way we rewrote it last time was called slope-intercept. Another way you can write the equation of a line is called point-slope. And it's useful when you're given a point and a slope, and you don't know the y-intercept. So this is an alternate way to write the equation of a line. There are 3 things you need to fill in for in this one. y1, m, x1. So everything that I put a box around, you have to fill in for those 3 things when you write the answer. The x1 and the y1 is a coordinate, and the m is your slope. So let's try an example where we're given a point and a slope, and we'll use that formula to write the equation of the line. So they want us to find the equation of a line that has a slope of 1/2. And not only does my line have to have a slope of 1/2, it has to pass through the point -2, 3. All right, so what I'm going to do first, kind of like what I do in the quadratic formula off to the side, I'm just going to identify what my 3 letters are. x1, y1, and m. Okay. What is x1 in this case? Well, Maddie, what's x1? Yep, that's the x value of the coordinate they give you. So that's -2. Jazaro, what's y1? That's 3. Good. And what about m? Eileen, what's m in this case? 1/2. Yep. Okay, so now we know what number goes with what letter. We're going to fill them all into that formula. So let's start with y minus y1 equals m times x minus x1. So m times x. Now it's x minus x1. What's going to happen when I fill that in my problem? It's going to be a positive. It's going to be x minus minus 2. So that's going to become plus 2. And that is the answer. In point slope form. If they wanted that in y equals mx plus b, we could do it, just like I showed you the last problem. First, you'd have to distribute out the 1/2, and then you'd have to add 3, and you could get y by itself. But this one didn't ask us to do that. Any questions on that? Okay. When we draw lines, there are two special cases of lines that we can have when we're comparing two lines to each other and looking at their slopes. Does anybody remember when you have two parallel lines, what's the connection between their slopes if they're parallel? Yeah?
They're exactly the same.
The slopes are the same. And how about the y-intercepts? They're different. Why couldn't those be the same? What would happen if you had two lines with the same slope and the same y-intercept? They wouldn't be parallel? Yeah?
They just be right on top of each other.
They'd be right on top of each other. They're the same line. So for lines to be parallel, same slope, different y-intercept. So parallel, that's the easy one to remember. The slopes are the same. Perpendicular, a little harder to remember. Does anybody remember when you have two lines that are perpendicular, what's the connection between their slopes? It's actually two things. They're blank, blank. Yeah?
Isn't their slope like opposite?
Opposite is part of it. So the slopes have to be opposites, like one's positive, one's negative, and something else. Yeah?
Yeah. Inverse slope was like a 2 divided by 3 would be 3 divided by 2.
Yes, reciprocal. Yep. So the slopes have to be opposite reciprocals. So for example, 2 divided by 3, the opposite reciprocal is negative 3 divided by 2. So the kind of problem you would see with this is it'll give you some information and then ask you to find an equation that's parallel or perpendicular. Kind of like we did the last one. Now this one is going to be set up to use point slope again. How do I know that? They're giving me a point right here. All I need is the slope. Now they don't tell me the slope, but they tell me something I can use to find the slope. They say that I have to be parallel to that. So in a sense, that does tell me what the slope should be. I just need to figure it out. I need to be parallel to that. So does parallel mean I want same slope or opposite reciprocal? Yep. Same slope. How am I going to find the slope of this? Because I have to be the same. So I need to know what this is. Yep.
You turn to y equals mx plus b.
Yeah, turn that into y equals mx plus b. So 3x minus 2y equals 1. I mean, you can do it lots of different ways. You got to get y by itself. I would just bring the 3x to the other side. And then divide by negative 2. So that's gone. And now when I divide by negative 2, where do I have to do it?
Oh, left side.
And
On the right.
Yep, we got to do it there, and we got to do it over here, just like that. Negative divided by negative, that's gone. Negative divided by negative, that's gone. I don't even need to keep simplifying this. I only wanted to know one thing. I wanted to know the slope. When we look at that, what's my slope? 3 over 2. And I want it to be parallel. So that means use the exact same slope. So there's your slope. There's your x1. And there's your y1. From here, it's exactly the same as the last problem. Slope, x1, y1. I guess we'll just finish it off. How about Casey, can you tell me what I'm going to have in front when I write my final answer?
Be y equals 2.
Yes, because it's going to be y minus y1, but y1 is a negative. So y plus 2 equals, oops, I need to fill in for m. M is 3/2 times, and y, what am I going to have inside the parentheses?
1.
Anything else?
X.
And so we're
X minus 1.
x minus 1. Yeah. And there's your answer. Whoop, sorry. Any question on that?
So that was the question on the test. Would that just be the answer for it?
Yeah, they weren't very specific about the type of equation. They just said write an equation. So there you go. I wrote an equation. If they said to write an equation in slope-intercept form, then you'd have to go a little bit further and get the y by itself. Okay, so the last thing. So the last thing is how we draw not just a line, but an inequality. If you don't remember, this is basically kind of like this. You have to decide if you have a solid or a dotted line, and then you either shade above or shade below. People remember doing that kind of stuff? Okay, that's basically what this is. So to graph a linear inequality, you first graph just the line. Now I have a chart that I'm going to show you that describes when do you shade above, when do you shade below, when do you make your boundary solid, and when do you make it dotted. But does anybody remember when it's a dotted line? Yeah?
If it doesn't matter, it's like not equal to.
Right, if it doesn't have the equal to, that's going to make it a dotted line or dashed line. So if it's less than or greater than, it's going to be a dashed line. If it has the equal to under it, that makes it a solid line. Then, depending on if it's a greater than or a less than, you either shade above or shade below. Just to make this very clear. If it's a less than symbol, you're always going to shade below the line. If it's a greater than symbol, you shade above the line. So we'll finish up with one example of that, but I'll just give people a minute to copy that down. All right. So this kind of problem, on Edge Elastic, I would help you if you get stuck. But there's a button you can click that will shade below for you or shade above. If you didn't know where that button was when you take a test, it would help you find it. So don't worry about that. Okay. So let's graph that inequality. To graph it, I do need to rewrite it a little bit, but I can already tell whether it's going to be a solid or a dotted line. I should be able to see that right away. Is this one solid or dotted? Yep. It's going to be dotted. Okay, so keep that in mind. And what do we want to do here to make this easier to graph? Yes? Get the y by itself. Ashley, what would be my first step to get y by itself? What would be your first step to get y by itself?
To get y by itself?
Yeah.
Move it to the other side.
Okay, so tell me what to write.
3y.
Okay.
Both sides.
Now, I will warn you, if you subtract 3y, we're going to end up with a negative number next to y. Then we're going to be having to divide through by a negative, which now we have to remember to flip the inequality. So if we subtract 3y from both sides, it's okay, but we're adding a lot of steps in. Yep.
Subtract 4 from both sides, right? Would that be...
So if I'm trying to get y by itself, I don't want to put more stuff with the y. I want to take things that are on the same side of the y. And,
I'm thinking it's solving, sorry.
yeah. Well, we're solving, but we're solving for y. Yep.
Subtract the x.
And how many x's do we have?
2.
2. So I would subtract the 2x. Let's move that over here. Okay, so now that's gone. Just put that there. I know it's not y equals mx plus b. I'll fix that. But that's fine for now. And what would my last step be? Yeah?
Divide by 3.
And remember to do it here, here, and here. So that's going to be, and I divided by positive 3, so I don't need to flip the inequality. So that's fine. So y is less than, there's my slope, negative 2/3 x. And my y-intercept is 4/3, which is 1 1/3. Thinking of it as a mixed number, that's easier to graph it that way. So 1 1/3. So put your y-intercept. And then from the y-intercept, how do I move to get the next point on the graph? Up or down, how many? And then left or right, how many? Yep.
4/3.
That's my y-intercept.
Oh, yeah.
So that's
down
that's
two,
done.
Down 2/3.
Down 2, which way's over?
The right.
To the right, towards the door, right?
Yeah.
Yeah. So down 2, right 3. So down 2, right 3. And do it again. Down 2, right 3. Do it again. You do as many times as you want. There you go. And we said early on that this was supposed to be dotted. So draw a line through those points and just make it dotted. I'm just going to make it so I can see it on the screen for a second. Probably about like that. Put that line there. And make it dotted. I'll zoom in so you can see it. Alright, so I have a dotted line. And the last thing is, where am I supposed to shade? Above or below? Above. Yeah, this is a less than. So whenever we have a less than, we shade below. So shade everything under that line. Shade that whole area. Okay, that's your answer. Any questions on that? So we covered a lot of stuff in 1.4, but hopefully most of that was review. I think maybe the only thing that was new is how to calculate a maximum on the calculator, if we hadn't done that before. Alright, so that's the second part of 1.3 and 1.4. Okay, so the first part of the homework, that's on calculating maximums, and I think there's a pool problem like we did in class. And the second part of the homework, that's on like the y equals mx plus b, parallel, perpendicular kind of stuff. Right, so we'll take a look at those. You guys have about 13, 14 minutes. So if you want to start on it, you can. If you have any questions you want to talk to me about, now would be a good time.